Today we are going to start a new chapter, chapter number 4, Chemical Bonding and Molecular Structure. The points in the syllabus: Coastal-Lewis approach to chemical bonding, octet rule, its application to electrovalent and covalent bond. Today we are going to study only electrovalent compound, which are very familiar to you from 7th standard onwards. In 7th standard, a few examples of electrovalent compounds are there. Therefore, I am going to explain only one example of electrovalent compound. The other compounds which are mentioned in the syllabus, please try to do by yourself following the same steps. Atomic number, you can get it from the periodic table. For each compound, atomic number may be required. After completing all the examples mentioned in the syllabus, please refer textbook. All the steps and answers are given there. Please do the correction by yourself. W. Coastal and G. N. Lewis visualized that noble gases do not take part in chemical reactions under ordinary set of conditions and concluded that electronic configuration of noble gas atoms are stable. On the basis of this conclusion, they proposed a theory of valency known as electronic theory of valency. According to Coastal and Lewis, during the formation of a chemical bond, atoms combine together by gaining or losing or sharing electrons in such a way that they acquire stable noble gas configuration. This is Coastal and Lewis approach. Now, octet rule. During the formation of a molecule, an atom of a particular element gains, loses or shares electron until it acquires a stable configuration of 8 electrons in its valence shell. The octet rule is found to be very useful in explaining the normal valency of elements and in the study of chemical combinations of atoms leading to the formation of molecules. Ionic bond or electrovalent bond. Definition and examples. Ionic bond between two atoms is the electrostatic force of attraction which holds together the ions of the combining atoms formed by the complete transfer of one or more electrons from electropositive to electronegative atom. This is the definition of ionic bond. Now in the syllabus, the examples given are sodium chloride, lithium oxide, magnesium oxide, calcium oxide, magnesium fluoride and sodium sulfide. Other few examples are also given in the textbook. No need to study that. What is given in the syllabus, you study. I will explain sodium chloride. First of all, you should know the chemical formula. Write the chemical formula first. Formation of sodium chloride. You can in bracket, you can write NaCl. The formula is important. Now, by 2 steps, the transference and the formation of the molecule take place. Step 1. Write the electronic configuration of sodium and represent the outermost shell of electrons. How many electrons are there? Only the representation outermost is required. In lower classes, we make the children to draw K shell, L shell and M shell and all the electrons, and after transferring the removal of one shell, that and all, no need at all. You draw like this, you mention K shell 2 electron, L shell 8 electron and M shell 1 electron. Atomic number of sodium is 11. You write that first, then only write the electronic configuration. Similarly, chlorine electronic configuration, chlorine atomic number is 17. Write that. Then you write 287 and represent the outermost shell, how many electron it contains, that is 7. If you uses different notations for electrons for different element, it is easy to understand the transference of electron. For example, Na, the electron is represented like this, chlorine represented like this. Therefore, transfer, put an arrow and above that you write transfer. In the marking scheme for this there is half mark. Therefore, transfer and put an arrow head near the space provided to put this electron. Now, this will give you Na plus. Now the electronic configuration, make a note. Now it is only 2 and 8. Don't write 1 again. And instead of that, put a plus sign. And chlorine gains 1 electron, therefore negative charge. All these points are very, very important. Step 2, sodium, that is 2,8. Write the electronic configuration again, plus charge. That is a must. Chlorine minus charge, electronic configuration 288. And gives Na plus Cl. That is an electrostatic attraction between them. One more diagram is given in your textbook. No need, you can write this as the second step. Other examples follow the same steps. Atomic number, refer from the periodic table. See, the other examples are 1. Lithium oxide, 2. Magnesium oxide, 3. Calcium oxide, 4. Magnesium fluoride, 5. Sodium sulfide.